Hello, hello. All right, so I know I need to shave. This is true. I'll do it tomorrow. Don't worry. And today I wanted to start a series for Ethernaut. So we just finished up the Security Bootcamp. So if you want to check out those videos, feel free. So after learning a lot about the theory and about different types of exploits and bugs and practices and techniques, etc., I wanted to actually apply that to some of the practical applications of Ethernaut, a CTF. This CTF is one of the most, I think, recommended CTFs that I've come across. There's a series of CTFs that I want to do, but this is the first one I want to start with because it's kind of beginner friendly and it really introduces you to the Ethereum blockchain and how to interact with it, and also really tinker with contracts. So with that being said, this is probably not going to be like many of the other Ethernet video series you find on the interwebs or YouTube, mainly due to the fact that I'm going to try to go not as deep as possible, but go deep enough to the point where I have an understanding of what the lesson that needs to be learned from each session. So I'm not just going to solve the challenge and move on. I'm going to dive a bit deeper, but I'll ensure for the people that want to just see the answer and see how I've solved it, I'll do that in the beginning, and then after that we'll dive into the details. So first things first is when you go into here, there's a series of steps you want to take. They kind of walk you through the introductory area here, and they kind of give you steps on what you need to do, what you need to have set up to actually do this challenge correctly. So first and foremost, you need Metamask. Why do you need Metamask? Well, Metamask is simply a crypto wallet that allows you to interact with the blockchain. So if you look up here, in this corner here, you'll see that I have a little fox here, and that fox is for Metamask. And I also have some notes here that we can go through together. So Metamask, and I have a bunch of random art in here, so I'm just amazed by how kick-ass the art is in the crypto community. People just put so much effort into random things, and this is a great piece for Metamask. So Metamask is a crypto wallet, but it's more than just a crypto wallet. It's a way to interact with the blockchain to test your dApps in your smart contracts through a way of testnets. So if I open this up here, you'll see that there's different types of testnets here. So there's the Ethereum mainnet, which everybody knows and loves. There's a series of other ones I've added myself, but down here you'll see some that are associated to Ethereum. We're actually going to play on a Rinkeby. The reason we're playing with that one is that it actually asks you to do so. So first things first, set up your MetaMask. Next is opening up the console. So there's many ways you can do this. If you're using Firefox, you can do, I think it's just Control-Shift-I, usually is, but that little thing got in the way. So if you just do right click, open up the inspect page, you'll see that we have our console here. So most of the time, I think we're just going to play with the console and not really touch anything else. So you can open that up, and here you're going to see it's asking you a few questions and a little prompt. So here it states that I should put player into the console. So let's do that. If you type out player, you'll see that it starts to autofill that, and actually autofills the response as well, which is really interesting. But here it's asking us basically inside of the console, inside of the inspect page for the website, they want us to type in this command into the terminal. And if you do that, you'll get back your address. So this address is representing our address for the Ethereum wallet. So if you come here, you can see that it's the same thing. That's all good and dandy. The next thing is we're going to scroll down and we're going to look at some of the helper functions. So you can see that basically it states another thing is like here, hey, put in some more fields and play around with some stuff. I think they're doing this mainly just to get you into the feel of playing with things and typing stuff in. So you can see I've done get balance and I'm not putting in a field there, and that is because there's supposed to be a parameter. So let's try that again, but this time doing that. And I've said get balance for the player, and it shows you that my balance is this, and we can validate that's correct by looking at our MetaMask and seeing, okay, it's 0.961, this is 0.961, so this is obviously rounded up because this decimal is a lot larger. So we have that response there. Another thing here, it states that if you're using Chrome v62, you can do a wait, so it looks a little prettier. So instead of getting that response back, we can actually just get the value instead of the entire promise back from that. Okay, so we've done that. We can do it with the helper function. If we do the helper function, it's going to give us a whole bunch of information that's actually useful that I would recommend looking at if you're doing this challenge. It's just going through this table and looking at, okay, what are the helper functions and what do they do? So it basically walks you through all the different functions you can type in, the parameters associated to each, and then the definitions for those. So with that being said, let's go to the next piece. All right, so in the Ethernaut contract, it's asking me to type in Ethernaut and see what comes back. So I will do that. And if we do this, we can see that it's coming back with the contract, and it states that here. So if you expand the Ethernaut object inside of that, it should show some of the variables and associated objects for that. So if we look at this, we can see it's a massive JSON object with a bunch of information. A lot of these items are associated to the contract that we're interacting with right here. And if we scroll through here, you'll see some stuff that you may have seen in different source code for contracts you've reviewed, one of which is constructor. So if we go to this, you can see that we have the constructor mentioned here. We can see there's a contract mentioned here, events that are emitted that you can see for logging purposes, different methods included, the owner, send transaction, transfer ownership. So these are all different ways that we can interact with the contract itself. And a really important piece that we'll dive into in more depth for the very end of this specific opening challenge is looking at the ABI. So the ABI is, I think it's application binary interface or something like that. I have it listed. Let's go to my notes. Application binary interface, yeah. So I'll explain this in more depth, but you can see that inside of this application binary interface, there's a series of options here, and it's basically a bunch of functions and events. So if you look at the end and not the beginning, just to kind of not throw yourself off, you can see these are a series of events that are being emitted. There's a series of functions that we can interact with, and here it tells you the type of function it is. So is it payable? Is it not payable? Is it a view function? All that kinds of stuff. So that's that ABI, and that's going to be important later on, but we'll jump into that later. So we've done the step they asked us to. So we've typed in ether contract or Ethernaut, and we've seen what come back. And we've read through it, and we tried to understand it. Okay, now it's asking us to interact with the ABI. So the ABI is something I just referred to, and I guess we can dive into the details now while we're on it. But before I go any further, there's some stuff I wanted to mention here. So when you're going through this process of setting up your Metamask wallet, you're going to want to go to a faucet. So a faucet within the cryptocurrency world is basically a way to get quote unquote free crypto, or sometimes you have to do tasks to get it. I've not interacted with anything that is outside of testnet faucets, mainly due to the fact that my understanding is that most faucets here that are not associated to the testnet are somewhat scams. So yeah, stay away from those. But really, the point of a faucet is basically to give you tokens so you can then interact with the testnet to run contracts and do types of tests when your contract's deployed. So you can basically do as much testing as possible before you go to the mainnet. And you need tokens to actually interact with the contracts because of gas and all that stuff. Here's another great piece of artwork. All right, the next piece is Rinkeby. So Rinkeby is the testnet they want us to interact with. And I've mentioned some notes here that we can look through. Really, the parts that I wanted to point out here are, okay, so there's a few things I want to mention here. So first things first with Rinkeby, this is the testnet we're using, but there are multiple testnets that you can actually deploy to and practice or test out and modify your contracts before going to mainnet. So that's one point I wanted to point out here, is that there's different alternatives that are available. Additionally, the point of a testnet, I've already mentioned this, is to basically ensure that the dApps and smart contracts you're putting out there have been tested and thoroughly modified. One issue with this and many other things in Web 2 and Web 3 is that the testnet you're interacting with is not identical to production, which is a common occurrence in Web 2, and it's an issue in Web 3 as well. There's a lot of variables that actually are hard to solidify and put inside of a testnet to mimic exactly what's happening on the mainnet. So there are some spooky actions at a distance that occur when you're actually in production, but you can try to reproduce as much as production as possible in the testnet to ensure that you're putting out something that's safe, secure, and efficient. And the next thing here is Rinkeby, is the one that we're using, and Rinkeby uses a clique consensus protocol. Didn't research that. I know what proof of authority is, so basically federating your vote to somebody else, and there's no value in the ETH. So the ETH there has no actual value. The next thing are there's alternatives. So the other point I wanted to point out here is that you can see that Rinkeby is the one we're using here, but there are other options. So there's Morden, Ropsten, and Coven. Little fun fact, I was trying to figure out why these are named the way they are, and somebody on Stack Exchange answered the question for me. So you can see that each of these are named after train stations in different locations where I think some of the developers that originated on kind of created a lot of these test nets, that's where they were based or they were fond of. So London, Stockholm, and Singapore. And just another photo, just to explain there's different test nets, your wallet, and how you interact with that. And the next thing is ABI. So this is what I wanted to get back to based off of the 0.5 that we came across here in this opening challenge. So ABI, Application Binary Interface. And the premises of an ABI is somewhat new to me and new to a lot of folks that are getting into this. And the way to simply explain this is that an ABI is a way for your source code to be encoded as it's compiled so you can interact with it on the chain. And when encoding your source code, when it goes from source to binary, as it goes through that process, you're going to encode certain functions and the parameters that go inside of those functions and a bunch of other information that's happening there. Reason being is that when your code is deployed in the when your code is deployed on the blockchain, it's in binary. And we need to have a way for other smart contracts to interact with our smart contract in a understandable and a repeatable fashion. And if we scroll down through here, there's a few links I've linked here. So this first one here is linking out to this website here. And I found that this explanation is probably one of the better ones that I've come across that explains the application binary interface. And inside of this explanation, they actually give you some examples of what's happening here. So here we can see there's source code, and I've zoomed in probably too much, so let's zoom out a bit. Maybe not. Okay. So here you can see that we have our contract, right? And in our contract, we have a function, a function, and a function. And as we're going to encode this, this BAS function here, you can see down here is as we're encoding that, when a function is encoded and compiled down, it's going to have the first 4 bytes are going to be associated to that function name. So these 4 bytes here represent BAS above. And so when this contract is then called by another contract, when it's deployed on the blockchain in this binary format, that contract knows to look for this signature associated to this function BAS if it wants to execute that specific function. And then down here you can see additional information was encoded as well. So this BAS function takes in a series of parameters. One is a uint32 and a boolean. So we can see that uint32, we've given it a value of 69, and this is what that looks like when it's encoded. The same thing for true, as this is what that looks like when it's encoded, as well as compiled down to binary. So this is just the simplistic example of what the ABI process does, is it takes the binary, encodes it so then other contracts can interact. And if we come back here, I also have another link to the Ethereum Mastering Ethereum book, and there's a specific section in here that I've linked into. I'll link into the YouTube channel, but they explain inside of this here as well kind of what the ABI does and its purpose. And I highly recommend, if you've not read this, is if you're interested in Ethereum and all that stuff, and you're interested in kind of understanding the security and all aspects of Solidity, read this book. It's free, it's on GitHub, and it's actually pretty well written. But this photo here is the photo I wanted to get to. So here you can see there's a few items here that I wanted to point out. So here we have we're writing to Ethereum and we're reading from Ethereum. So this is the dividing line between when our contract is deployed, D, and when we're actually deploying. So we'll say DP for deploying, and this will be DO for deployed, I guess, whatever. And specifically, we have a few things here. So we have the front end of our code. So this is our source code that we're going to compile. So as we compile that source code, you can see here, there's a few things that are happening. So we're actually going to take that source code and put it into bytecode, binary. So then as that's occurring, we're also going to do the encoding for ABI. So in the future, web apps can actually use that encoding to interact with our contract. So once we've deployed this to the blockchains, if we go over here, we're going to see that as others want to interact with this, and like wallets, dApps, fill in the blank, they're going to want to interact with the ABI so they know what specific functions and parameters and data that needs to be returned when interacting with that. So these are two really key components to interact with the blockchain, and understanding kind of how the ABI functions is important, especially if you want to dive deeper into the contracts. And the point that I wanted to make here is basically this opening challenge is giving you an understanding of how just to interact with contracts in the blockchain and how to use the wallet, the console, and the web browser and all that stuff. So with all that being said, let's get to solving the challenge. So if we come here, we can see it asks us to interact with it some more. So it wants us to put an Ethernaut, and it wants to actually have us look at the owner. And if we open this up, we'll see that the owner is this number here. So that's obviously not our address. So if you look at our address, we're at 3D. This is 099. So that's one thing it's pointing out. So you can see who the owner is of the Ethernaut contract. And now it's asking you to do the faucet. So we've already done the faucet, or you'll do the faucet when you go through here, and it gives you 3 options. Very straightforward. You just drop in your address, ask for Ether, and then you magically get free Ether. Now, get a level instance. So when playing a level, you don't interact directly with the Ethernaut contract. Instead, you ask for a level instance. To do so, click the button at the bottom of the page. So we need an instance of the contract instead of interacting directly with the contract itself. And the way I think about the reason why kind of you would want to get an instance instead of interacting directly with contracts is similar to Git or Git versioning, where you have like your master branch, and you don't necessarily want to interact with the master branch, or sometimes you don't even want to interact with the feature branch. You want to have your own dev branch, right? So you have everything moving here, and they say this is the main Ethernet contract here. We're actually going to come down here, we're going to create our own instance of this so we can then tinker with this instance, and as we're tinkering with it, once we're finished, then we can submit. You can see we can submit that instance back into here, and it can confirm if we did things correctly, and if we did, then we get to move on to the next level, level 2. So that's kind of like how I pictured that in my head. So here you can see we're at this instance. This is our own specific instance of our address, which is great. So now that we have our own instance, we should go into the next step. So now it wants us to inspect contract. So it looks like we have some more options now. So this contract here is the contract that we're going to look at. And if we open this up, we'll see that this is slightly different than the Ethernaut option that we did. And here we have a bunch of information, right? So we have a series of function calls. You can see it states function call. But if you go back to the instructions, probably should figure out a better way to do this so it's faster. All right, so here at the very end, it says, okay, so we have a bunch of information. It says do contract, look through all the variables, the functions and stuff, see what it's made of. Next, it says, all right, now I want you to look into this level for info, look into the info method, and then you should be able to find basically the password for the next level. And it gives you a hint here. It says, look at the contracts ABI. So if we scroll up here, and we look through all this information, if we open up the ABI, we're going to see some information here, right? So all of these options here we can interact with, which is kind of a beauty of this. And as I stated previously, we kind of, I don't know, for some reason for me, it's easier just to kind of look at the end first, just to get an idea of what we're looking at. So we have a constructor, and we have a series of functions. Of these functions, some are non-payable, some are view functions, some are pure functions, and that's kind of those options there. And then we can see the naming of these. So we have, you can authenticate, you have a series of info options, you have some method option, another method option, and a password option. So if we look back at our instructions, there should be an ask to do certain methods. So here it's asking us to do the await contract.info. So if we do it correctly, and actually type info with an O, not a 0, we get a response. And I'm using await. So here you can do contract info or await. Like I said, await's just a little cleaner. So if you do the contract info, it just gives you the entire promise, and you have to scroll down to the bottom to get the value here. But if you do await, it just gives you the value directly, which is a little nicer. So it says, okay, do Ether 1. So we're going to do Ether 1. All right, it says now do Ether 2. But if we do Ether 2 without anything, you're going to see you're getting an error. And the reason you got an error is because there's a parameter it's seeking. And the reason that we know this is, first, the error is saying you gave us 0 and we expected 1. But also, in addition to that, if we go back to our await contract and we open this up and we look back at our ABI here and we make this a little larger, Oh no. Okay, here we go. We go to the larger and we said Ether2 was the one we input. And here specifically, you can see that if we're looking through this, we know that Ether2 is a function. So you can see here that it's looking for an input. And the reason we know that is because the length here is 1. So it's seeking a string, so a type string, and it's seeking a parameter. And if we look at the other options that didn't have parameters, we open these up, you can see that the input array for that object is 0. So we know that if we look at the ABI, we can kind of discern the difference between something that takes parameters and doesn't take parameters, and the associated parameters that are taken for that ABI specific object in there. So if we come back down here and we put in info2, we can see it's looking for a string. And the previous method prior, info1, says for us to put hello in there. So if we go back to 2 and we put in hello, we're going to get a response back, which is correct. So we did the right thing. And here you see, okay, the property info_num holds the number for the next info method to call. So, okay. So if we go back here, let's do info_num, and we will go blank. Okay, so we have something back. And if we open up the object that responded back, we can see it's a length of 1, negative, null, etc., etc. So words array 42. Okay, so it's given us the number 42. So if we go back to the contract, so let's say contract. So if we open this up, go back to our ABI, we look here. So we just did info2. We did hello. It said info42, so we got the 42 back from that. And if we open this up, we can see that the input for this was 0, but the output from this was 1, and the output provided back to us was 42. And actually, no, it was info_num, I think? Sorry, so we did info_num, 42 came back from that. Okay, so it says 42, and the reason it says 42 is basically stating that your next answer is 42. Like the next thing you need to do is 42. So if we do this, we'll get another option from this method, and the reason we knew to do info42 is because it told us to do 42. And if we come back here and we do another one that it's asking us to do method name, it comes back with another response and said, okay, the method name is this. So okay, we're going to do that now. So we'll say method this, do this. Okay, so if you know the password, submit it to authenticate. All right, so this is where I got a little confused. But after kind of tinkering around some stuff, I realized that I was basically interacting with every single method except for the one method that had the answer. And if you look through all of these, you'll see that we've basically have done every single method. So we've done info, we've done 1, 2, 42, num, method, method name. So we've done all these. We've not done authenticate, get cleared, or password. So if we look at authenticate here, we can see that it takes an input. And the input it takes is a string, which is going to be our password. And the output's going to be nothing here. Get cleared, is there an input here? No input, output. Basically tells us if we're cleared or not. You can see it's a Boolean. And then our password here takes 0 input, but it does have an output, and the output is a string. That string is going to hopefully be our answer. So if we do contract password, you can see, boom, Ethernaut 0 is going to be our password. So now we're going to want to actually submit that to the correct thing, if I can spell this correctly. So contract, authenticate, and then we're going to put in Ethernaut 0. And once we've done that, it's going to go off and basically connect us to a new address. So you can see it has a new address here. So it clicks here to add this to your address book. And then we can add a nickname here. So we can just say eth2, save that, confirm. And now what's happening is it's sending the transaction to the Rinkeby testnet. And we can actually select this link. And once we select it, it'll take us to Etherscan for the Rinkeby testnet. And you can see that it's going to take a few seconds to actually complete. And this is one of the realistic aspects of the testnet, because like I said, this is using the click protocol that has proof of authority. So there are miners mining on the testnet for Rinkeby, and as they're mining, you have to wait for them to finish that block. So once that block's finished, then you can see the completed transaction. And if we jump back here, we can see that it was mined. And at the bottom here, it basically states that you should have all you need to complete the level when you know that you've completed the level, submit the contract using the orange button at the bottom of the page. So we've completed it because we've authenticated ourselves. So if we submit instance, we say confirm. Now we've authenticated ourselves and we've submitted our instance back into the main contract. And this kind of goes back to the point that I made around, remember the Git versioning thing? So we have our situation here where we're going over and we submitted it back. And you can see that level was completed. Hello, you've successfully completed this. And then below that, it's actually going to give us the source code. So you can move on to the next level, or as I would recommend, is actually look through the source code. So I've copied and pasted this out into its own VS code here so I can walk you through it. And if we look through here, there's a few items, right? So first things first is we can see that the Solidity version they're using is 0.6, and they're using floating point. Remember, if you did any of the security stuff, you know this is a bad practice. When you deploy something to production, it should be frozen in the versioning that you're using for the compiler. It shouldn't be a floating point where you're saying 6 and above. It should be 6.2, and that's nothing varies because you don't want any surprises. So that's one thing. That's first. And then the next thing you can see our contract here. So we have our contract instance. There's a series of state variables that are all being created. So we have a series of strings here, uints and booleans. Some of this stuff should be familiar. So remember, we saw 42 when we interacted with it. We saw this string when we interacted with it. And let's go down to the constructor. So the constructor actually contains the password, what we're looking for, and this password sits in memory. Some more information. So we have some functions here. So this function is the info function that we interacted with, and this one basically is a public pure function. So basically all it's going to do is return that string from memory, and that string is the one that we interacted with. The same thing applies for everything below that, almost it. So you can see a public pure function, and it returns that string that we interacted with. So this one's slightly different, but it's something we've already done. So you can see this is the one that took the parameter that we put into it, and that, remember, that was going to be the hello. So when we input hello into this, it's then going to basically check to see is hello, when it's encoded into the ABI for this kakak. It's basically SHA-3, but not tainted by CIA or whatever the issue was there. They check your parameter against this string, and if they match, then it returns true, and it says congratulations. You should go to the next piece, which is info num. And if we keep moving through here, we should keep reviewing the code. Okay, what's next? So we have some more functions here. So this function 42 is something we've interacted with as well. So we can see that this basically, you put this in and it gave us back this option. So we then put that option in, but there is no function for this. And that like threw me off for a second, but then I realized and I remembered that when we input this, it just responded the state variable. So it just kicked back the state variable for us. And then we put in this one, which then kicked back this option here. And you can see that the authenticate is the one that we put our password into, because it's basically a function that actually takes another parameter, and that passkey is going to be the parameter we put in there. So that's going to be the string Ethernaut 0. And it's a public function, and it's basically going to say, okay, if the password that is saved up top in that state variable matches the parameter that we put in there for the passkey, then it's going to basically change cleared to true. And once cleared is changed to true, it's going to basically allow us to authenticate and pass to the next level. And we have the function get cleared here. That's going to basically check and say, okay, it's going to return cleared, and it'll probably kick that cleared back to false after it's complete. So that was probably not the greatest explanation, but it was a lot of diving in for me, and I hope it was useful for you. And I'll see you on the next Ethernaut challenge.